11.4, circumference and arc length. Our goals in this section are to find the circumference of a circle and the length of a circular arc, and use circumference and arc length to solve problems. First, let's discuss what is circumference and what is arc length. Circumference. Remember, circumference of a circle is the distance around the circle. Right? So you have a circle, and you want to know the distance all the way around the circle. This is circumference. Arc length is just a portion of that circumference. Okay? An arc length is a portion of the circumference. Remember, circumference is all the way around, and then arc length is just a portion, just a piece of that circumference. Let's look at how we find circumference, learn and review how to find circumference, and then we'll go into how to find the length of an arc. So let's start with circumference. There are two formulas that we can use to find circumference depending on what information is given to us. If you're given the diameter, the easiest way to find circumference is just to multiply pi times the diameter. Okay. But if you're not given the diameter, sometimes in some problems you're only given a radius. Remember, it takes 2 radii to equal your diameter. And so you can just multiply 2 times pi times the radius. 2 times the radius to equal the diameter. So circumference. Remember, circumference is the distance around the circle. 2 ways to find it. If you're given the diameter, just use pi times diameter. If you're given the radius, then you want 2 times that radius and then times pi. Usually the formula is written 2 times pi times r, but it's because we need 2 radii that we use this formula. Let's look at a couple of problems. We want to find the circumference of a circle that has a radius of 9. Since we're given the radius, let's use the formula that involves radius. We can say the circumference is equal to 2 times pi times the radius. So the circumference is equal to 2 times pi, put the radius in, 9. So we could say our circumference is equal to 18 times pi. Now in some answers, sometimes you will be asked to leave your answer in terms of pi. This is a good answer. We could say that this circumference of this circle is 18 pi inches. In some problems, they will tell you to use pi is approximately equal to 3.14. If you're asked to do this, then where pi is at, you could put in the 3.14. And you could say that it would be equal to 18 times the 3.14. And you could get an approximation for the circumference. Using your calculators, 18 times 3.14, and you would find that the circumference is 56.52. This is a better answer, but there is still a better answer than this. On your calculator, you have a pi button. Using the pi button will give you the best approximation of what the circumference is. So you could just say circumference is equal to 18 times pi. Use the pi button on your calculator. 18 times, hit the pi button on your calculator. On the calculator we're using in our class, we need to hit the shift. The pi is all the way down at the bottom, right in the center. Hit the equal sign. You're going to need to hit the S to D and turn that into a decimal answer. And we see that when we round it to the hundredths place, let's put the 56 point. I want you to see that it's 548. Let's talk about rounding here for a second. We want to round to the hundredths place, so we want to look at the 8 to determine will the 4 stay a 4 or will it round up. We would round this up to 56.55. This would be the better answer, right? In my class, I call this the good, better, and best answers. What I want you to do in my class is always follow directions. Always follow directions. I only want you to leave the answer in terms of pi if the directions tell you to leave the answer in terms of pi. I only want you to give me the better answer using 3.14 if the directions tell you to use the approximation 3.14 for pi. Most always, I want you to give me the best answer. This is the most exact answer. This is the best answer, and this is the one that I want you to give me the most of the time. So, when directions tell you to leave the answer in terms of pi, do this. When the directions tell you to use 3.14 for pi, do this. For all other instances, give the best answer and use the pi button on your calculator. Alright, let's look at another example. In this problem, we're asked to find the diameter. We're given the circumference and we're asked to find the diameter. So we should use the formula for circumference that has diameter in it. Circumference is equal to pi times the diameter. So all we need is to plug the circumference in, the 58, that is the circumference. That would be equal to pi times the diameter. To find what the diameter is, all we have to do is get rid of pi. Since it's pi times diameter, to get rid of pi, we will divide by pi. But remember, whatever you do on one side of the equation, you must also do on the other side of the equation. Since they don't tell us what to do with pi, we get the best answer by dividing 58 by pi on our calculator. 58 divided by pi, hitting the equal sign. It gives you 18.461. Remember, we want to determine, does the 6 stay a 6 or does it round up? We would round this to 18.46. So our diameter is approximately equal to 18.46. Alright, let's look at another example. This time you're asked to find the circumference. I'd like for you to pause the video and you give it a try. Alright, hopefully you saw that because they've given you the diameter, the best thing to do here is to use the formula that the circumference is equal to pi times the diameter. So the circumference would be equal to 25 times pi. Using your calculator, the circumference is approximately equal to 78.54 centimeters. Okay, move ahead. Alright, in this problem you're asked to find the radius. You're given the circumference and asked to find the radius. Pause the video, give it a try. I'm hoping that you had paused this video and given it a try yourself, and I'm hoping that you realize since that you were given the circumference and asked to find the radius, that you chose to use the formula circumference is equal to 2 times pi times the radius. The circumference is 70 feet, and what you want is the radius. You should have divided both sides by 2 pi. Now, the common error here, when students punch this into their calculator, they want to do 70 divided by 2 times pi. Make sure that you're taking 70 and you're dividing it by 2 and you're dividing it by pi. You should have gotten the answer 11.14. The radius is approximately 11.14 feet. Okay. If you did not get 11.14 feet, make sure that when you punched it into your calculator, you either punched it in as a fraction, 70 over 2 pi. If your calculator would not let you punch it in this way, you can punch it in as 70 divided by 2 divided by pi. Okay? All right. Let's talk about arc length. Remember, arc length is a portion of the circumference. There's two ways to set this problem up. In a circle, we could find the arc length by setting up a proportion problem where we're saying that the length of the arc over 2 pi r is equal to the measure of the arc over 360. What we're doing is we're taking a piece of the circumference and putting it over the entire circumference. That's what we have here. A piece of the circumference over the entire circumference is equal to a piece of the measure of the circle, which is an arc length. That's a fraction of the entire distance or degree measure of a circle, and then this is the entire degree measure of the circle. Okay, so arc length over circumference would be equal to measure of an arc. Remember, arcs are measured in degrees over the total degree measure of a circle. So this is one way to do it, set it up as a proportion problem. Another way to do it, and what I find most of my students find a little bit simpler to set it up this way, to find the arc length, we can just think of the length of an arc as being a fraction of the circumference. Or 2 pi r, remember that's your circumference. Circumference is equal to 2 times pi times the radius. Okay? And then this gives us what fraction of the circumference that we're wanting. For instance, let's take this arc AB here. Okay, let's say that here we have a central angle of 30 degrees. Okay, well that 30 degrees is a portion of the entire degree measure of the circle. That 30 degrees is a fraction of the whole 360 degrees. This 30 over 360 tells me what fraction this arc is of the whole circumference. So to find the circumference here, we would take 30 over 360 times the circumference. Well, to find the circumference, we need a radius. Let's say the radius is 10. Okay. So I would have over here 2 times pi times 10. The 2 times pi times 10, this would give me the circumference, and then this gives me the fraction of that circumference. You could punch this whole thing into your calculator just as it appears there, 30 over the 360. Times 2 times the pi times the 10, and find that this arc length, arc AB, length of arc AB is approximately equal to 5.24. Alright, let's practice with this a couple of more times. I have 3 different circles. Let's look at just 8. I want to find the length of just arc AB. Okay. Now I know the measure of arc AB is 70 degrees. But that's just the measure of the arc. That's not the length. That's not the distance. That's just the degree measure. To find the length of arc AB, I need to know what fraction of the circumference arc AB is. So the fraction is 70 over 360. Because it's 70 degrees of the entire 360 degrees, I take that fraction and I multiply it times the entire circumference. And the circumference is found by taking 2 times pi times the radius. And the radius here is 4. Punch this into your calculators. 70 over 360 times 2 times pi times 4, and find that this circumference is approximately, this arc length is approximately 4.89 millimeters. Okay, let's look at circle B. Circle B, same thing. Okay. The measure of arc CD is 100 degrees. What we want to know is, what is the length of arc CD? The length of arc CD, remember, it would be a fraction of the circumference. Since the entire circle is 300 degrees, and this portion of the circle is 100 of that 360 degrees, we would say it is that fraction, 100 over 360, times the circumference. The circumference can be found by taking 2 times pi times the radius, and the radius here is 7. Punch this into your calculator. 100 over 360 times 2 times pi times the radius of 7. Round to the hundredths place and find that your your arc length is 12.22 millimeters. Alright, let's try this one more time. I'm going to need to erase some of this out of my way so we have some room. Alright, one more time. I want to find the length of arc EF. Remember, to find the length of an arc, you want the measure of the arc over 360 times the circumference. So the length of arc EF would be the fraction that arc EF is of the whole circle, which would be 140 over 360. This gives me the fractional portion that this arc is of the entire circle, and times the circumference. So we have just this fraction of the entire circumference. The circumference can be found by taking 2 times pi times the radius. Remember, circumference is equal to 2 times pi times the radius, or 2 times pi times 6. Punch it into your calculators. If you punched it in correctly, you should have gotten approximately 14.66 millimeters. Alright, done this for you now 3 times. Why don't you give it a try? Here's a couple of examples for you to practice. Pause the video, give each one of them a try, and then unpause the video and check your answers. Alright, if you solved checkpoint 3 correctly, you should have found that the length of arc AB is approximately 8.38 millimeters. If you solved checkpoint 4 correctly, you should have found that the length of arc MN is approximately 62.83 inches. Alright. That's the end of this video. See you in class.